Thank you, teaching. In this slide, we are going to talk about basic mechanisms of urine formation. Dear student, it is very important. Be careful, okay? Suppose that it is woman's capsule, okay? And for the simplicity, I'm going to show different parts of tubule as a straight tubule. Got it? Proximal tubule, loop membrane, distal tubule, all of them actually are shown as a straight tubule. Got it? Woman's capsule and tubules. Actually, as I told you, it is glomerular afferent arterioles, glomerular capillary, and efferent arterioles. Efferent arterioles. And here you can see peritubular capillary. Okay. Do you remember the amount of blood pressure here?
Yes, 60.
Thank you. Blood pressure here is 60 millimeter of mercury. Okay, for this reason, plasma is filtered. Okay, from glomerular capillary toward woman's capsule. Why did I say plasma is filtered? Say blood, the whole blood, okay, is composed of blood cells. Which type of cells?
RBC,
Red blood cells, white blood cells, platelets. They cannot be filtered here. Why? Because the size of cells
Also large.
is larger than the size of pores. Got it? Okay. Blood is composed of cells and plasma. Actually, in plasma, which components are seen? For example, proteins,
Water.
iron, water, waste products, okay, waste material or waste products, and so on. Okay. Don't forget, proteins cannot pass. Why? Because of the size and the charge. Because the size is larger than the pores, or as we will talk, actually negativity doesn't allow proteins to pass. Okay, we will talk about that. What is important up to here is that blood cells and proteins cannot be filtered. For this reason, we say this is plasma, which is filtered. Okay? Here we have filtration. Filtration by which transport mechanisms?
Simple diffusion.
Very good. Actually, by simple diffusion and osmosis for water. Osmosis is simple diffusion of water. Okay? We have filtration here, filtration by simple diffusion. Got it? And in peritubular capillary, we have reabsorption. The direction of reabsorption is in this way, from tubules toward peritubular capillary. It is the direction of reabsorption. I have a question. Do we have reabsorption here? Why? Why?
Regulating the plasma flow
The blood pressure and the capillary line,
What is high?
blood pressure.
Very good. Actually, high blood pressure here doesn't allow anything to be reabsorbed. Here, there is no reabsorption. Do we have secretion here? What's the difference between secretion and filtration? What do you think? What's the difference? Actually, filtration is infiltration. Substances can pass based on size and charge. Okay? Anything which is small in size can pass, for example. Anything. But in secretion, we have a specialized protein, okay, which has a ligand binding for actually binding site for something, for one substance, not for everything, okay? Secretion is completely, actually, it needs actually a specialized proteins, okay? But filtration doesn't need any specialized protein. Any substance that can passes through Bowman's capsule. We will talk about filtration barrier, okay? And it will be clarified for you. Okay, secretion is done from peritubular toward tubules. Here, there is no reabsorption, there is no secretion, because we don't have a specialized protein for secretion of something. Got it? What remains here is called excretion. Okay, tell me please, excretion equals excretion equals, tell me please, we have three major actually mechanisms. Excretion equals filtration plus what? Plus which one? Plus secretion. Both are in one direction, toward the tubules, toward the nephrons. Got it? Plus secretion minus,
Yeah,
very good, minus reabsorption. Got it? In our body, may I write the quote? In our body, GFR, what is filtered is called filtron, okay? GFR is 125 milliliter per minute. Do you remember the amount of renal blood flow?
Yes.
1100 milliliter per minute. Okay? And how about renal plasma flow? 55% of blood is plasma. Okay? Actually, it equals 625 milliliter per minute. Got it? Was it clear? We have a formula for filtration fraction. What is filtration fraction? Volume of plasma which is filtered inside the Bowman's capsule is called filtration fraction. Volume of plasma, not blood. Okay, plasma. Why? Because blood cells cannot pass. Volume of plasma, which is filtered inside the Bowman's capsule. It is called filtration fraction. It is something about 20%. What does it mean? It means 20% of plasma is filtered inside the Bowman's capsule. Bowman's capsule, how many nephrons? 1 million or 2 millions? 2 millions, okay? Not one nephron, not one kidney. This amount is for 2 millions nephron. Got it? No question. Actually, we have talked about this before. GFR, GFR is 125 milliliter per minute. It is something about 180 liter per day. Okay? 125 milliliter of plasma is filtered inside the Bowman's capsule per minute. Okay? Reabsorption rate, actually from this amount, 124 milliliter per minute is reabsorbed, is removed from the tubules. Body returns back to the body. Was it clear? It is something about 178 liter per day. Okay? This amount is filtered, this amount is reabsorbed. What is urine volume? How much is urine volume? Urine volume is 1 milliliter per minute, am I right? Or 1.5 liter per day on average. Okay? No question? Was it clear? Was it clear? Yes or no?
Yes.
Yes. No question? Thank you for your participation. No question?
Doctor,
Yes?
should we remember all the numbers?
No, not at all. For example, I might ask you to calculate filtration fraction. Okay? I give the amounts. You have to memorize the formula. Filtration fraction is GFR divided by renal plasma flow, not blood flow. Okay? I give you renal blood flow, renal plasma flow, and GFR, for example. And I want you to calculate filtration fraction. You have to memorize the formula. Filtration fraction is GFR divided by renal plasma flow. Got it? That is memorizing. I have talked about the slide. In the slide, you can see the behavior of the kidneys with some substances. Okay. Typically, which substance is the smallest molecule in our body?
Ions.
Ions. Which ion? Actually, ions have different sizes. The smallest molecule in our body. I'm guiding you. It's not ion. It is molecule.
Hydrogen.
Water. Yes, water. الماء. ماء. علم. الماء. Okay. Actually, water is the smallest molecule in our body. Okay. It is thoroughly filtered. Okay. I'm gonna introduce the word thoroughly filtered. Water is thoroughly filtered. Okay. For example, we say sodium is thoroughly filtered too. What does it mean? It means sodium is filtered as thoroughly as water. Got it? For example, I say glucose is freely filtered. It means glucose is filtered as freely as water. Got it? Okay. Actually, these four substances are freely filtered. Okay? It means here in the Bomax capsule, they are filtered with this. What happens here? For substance A. Substance A is freely filtered. Do we have reabsorption for it?
No.
Do we have secretion?
No.
Tell me please, how much is excretion rate? Excretion equals what?
Infiltrate.
Equals what is filtered? Okay? GFR. In our body, we don't have a substance that the kidney behave in this way with it. Okay? Actually, have you heard inulin? Inulin. Inulin is not found in our body. Inulin. It is extracted from the roots of some plants. Okay? And it is injected to our body when we are gonna measure GFR in a patient. Body, it is freely filtered. Inulin is not found in our body normally. We have to inject it in order to calculate GFR. We measure concentration of inulin in urine, and based on the concentration of inulin in urine, we can measure GFR. We will talk about this part. Got it? Okay. In our body, we have no substance. With just filtration and no reabsorption, no separation. Here, substance B is freely filtered, okay? And as you can see, there is reabsorption for it. Excretion equals filtration plus reabsorption. Direction is in this way. Minus reabsorption. Okay. Actually, a lot of substance in our body actually are in this way in the kidneys, such as sodium, water, chloride ions, and so on. Okay? Substance C. Substance C is freely filtered too, and all of it is reabsorbed. Excretion rate is zero. There is no excretion. Why? Because all of these substance is reabsorbed. Got it? What is filtered is reabsorbed. In our body, actually, the body behaves with glucose and amino acids. Under normal condition, in a patient suffering from diabetes mellitus, what happens? Glucose concentration is very high. For this reason, all glucose cannot be reabsorbed. Glucose appears in the urine. But under normal condition, it is behavior of the kidney with glucose and amino acids. Body?
Yes.
No question? And the last one, substantive is freely filtered, and we have secretion for it. Okay, excretory rate, excretion equals, tell me please, filtration plus or minus secretion? Plus secretion. Very good. In our body, actually, body behaves with PAH, para-amino, hippuric acid, in this way. We will study about PAH in the next session when we are gonna measure renal blood flow. Okay? For measuring renal blood flow, we need it. For measuring GFR, we need it. Got it? In our body, we have, for example, secretion for creatinine. Okay, a waste material. No question? Very good. May I wipe the book? What is ultrafiltration? Filtration in Bowman's capsule is called ultrafiltration. What is definition? Passive movement of essentially protein-free fluid. Actually, by this one, I mean plasma. Okay? From capillaries to Bowman's capsule. Filtration barrier. I think you are familiar with 3 layers of filtration barrier. What is filtration barrier? Filtration barrier. In the capillary of all organs except the kidney, how many layers is seen in the capillaries? How many layers do we have? 2 layers. And the names are endothelial cells and basement membrane. Okay? These 2 layers are seen in the kidneys too. The first layer is endothelial cells. Actually, these cells are perforated. Okay? And the holes are called fenestra. Fenestra has negative charge. Got it? Actually, substances more than the size of fenestra cannot pass. Alright? It means fenestra separates substances based on the size. Why? Because substances larger than the size of fenestra cannot pass. Got it? It separates substances based on the size. Actually, fenestra has negative charges. It means it separates substances based on size and charge. Alright? It doesn't allow negatively charged ion to pass because it has negative charge. Was it clear? The second layer, as you know, is basement membrane. Basement membrane. Basement membrane is composed of collagen and some proteoglycans. Alright? Actually, they form a network. This network has a specialized size. Okay? Substances more than the size of this network cannot pass. In addition, this membrane has negative charges. Okay? It will because they are protein. Okay? It means this layer separates substances based on size and charge. Okay? We have an exception here. Filtration barrier here has 3 layers. Yes?
What is that?
Very good. Actually, it is regarding epithelial cells of what? Bowman's capsule. Actually, epithelial cells of Bowman capsule has foot-like processes. Okay, they are called podocytes. Podocytes and the pore of podocytes are called slit pore. Slit pore has a special size. Okay, substances larger than this size cannot pass. In addition, here podocytes have negative charge too. For this reason, we say this layer separates based on size and charge too. Got it? No question? clear? Not with the please. If you have any question, don't hesitate to ask. Okay, you can see 3 layers. And in this figure, fenestra, basement membrane, and acid pores. Another figure, fenestra, basement membrane, food-like processes. Another one, and here, it is very important, okay? We can synthesize some molecules, okay? Say synthetic molecules in different sizes, in different charges, okay? In this example, suppose that we have synthesized dextran. Dextran, neutral dextran without any charge, positive dextran, negative dextran, with different sizes. Okay. First, I want you to actually follow the blue line. Actually, the blue one is for neutral dextran. It means dextran without any charge. Okay, here you can see different sizes. Size increases in this way, okay? In this direction, size increases. Here you can see filterability. When we say filterability of something is 1, it means it is actually freely filtered. It passes as freely as water passes. Got it? Okay, pay attention to the neutral dextran. Just pay attention to this part, okay? As size increases, filterability decreases or increases? Filterability decreases. Got it? Actually, it shows the effect of size. The effect of filtration barrier, actually the size of filtration barrier. Got it? For example, substances in this size cannot pass. Filterability is 0. It means there is no passage. Got it? Now pay attention to polycationic dextran, the red one. As size increases, filterability decreases. But something which is worth mentioning, pay attention please. Something which is more worth mentioning is that at any size, for example at this size, as you can see, the filterability for positively charged ions, filterability for positive, is greater than the filterability for neutral substances. Got it? It means negativity of filtration barrier attracts positively charged ions more than neutral molecules. Got it? Got it? There is attraction between positive charges and negative charges. Okay, now pay attention to the black one. Actually, the black one is regarding polyanionic dextran. As you can see, even in this size, at this size, the smallest size, filterability is less than the filterability of neutral molecules and positive ions. But it means the negativity of filtration barrier doesn't allow negative ions to pass with these. Got it? And another one, for example, at this size, as you can see, filterability for anion is here. For neutral molecule is at this side. For positive is this. Okay? Please study the figures. Okay? In the exam, I might give you some figures. Okay? For example, I omit the words and here I put A, B, C. Which one is regarding positively charged ions? Which one is regarding negatively charged ions? Got it? Very good. Or for example, at a special size, filterability for which one is actually greater. Positively ions, neutral molecules, or negatively ions? Which one? In a special size. For positively charged ions, more than neutral and more than negatively charged. Did you get the point? Really? Just you stare at me. If you have any question, don't hesitate to ask, okay? In a disease which is called nephrotic syndrome, negativity is lost. Negativity of filtration barrier is lost. What happens? The body behaves in this way. Kidney behaves in this way with all molecules and ions, with positive ions, with negative ions, and neutral molecules. Because there is no negativity, there is no interaction between positive and negative ions. There is no repulsion between negative ions. Got it? And the last slide of this session is regarding actually comparison between some substances, molecular weight, and filterability. Pay attention, please. The smallest molecule is water with this molecular weight. Filterability for water is 1. Sodium, molecular weight of sodium increases. It means sodium diameter is greater than water, the size of sodium, okay? Filterability for sodium is 1. For glucose, as you can see, molecular weight, as molecular weight increases, we expect filterability decreases, but here you can see it is 1. For inulin, it is 1. For myoglobin, it is 0.75, and for albumin, it is very small. Okay, pay attention. Albumin is the most abundant protein in our body. Okay, it has no effect. Albumin, the size of albumin is 6 to 7 nanometer. The size of pores is 8 nanometer. It means the pores are permeable to albumin, but negative charges doesn't allow albumin to pass. But it is for this reason, filterability for albumin decreases. No question? Okay, you can take a break. 15 minutes. More than this. Let me check the time. Okay, see you at 3.
We have this session, the last doctor for you. Is it the same subject that you're studying? Sorry? No, no. Because this video you can review it. I actually understand. This is explain about your type.
Regarding the next.
This?
Yes, when we talk about the concentration of urine.
Well, it says the session
This session is 20, chapter 26. The
About-
session was 26, and the next one is 27. Okay, tomorrow we will talk about 24.